Hi everybody, today we're going to do a really quick recap of properties of logarithms. We're going to start with the product rule. So the product rule says if I have the log base b of the product of m times n, I can separate that into the log base b of m plus the log base b of n. So this says when I have multiplication, I can expand this to be addition. So let's take a look at what that looks like. Say I have the log base 3 of 9x, so I can expand that to the log base 3 of 9 plus the log base 3 of x. Notice this log base 3 of 9 is actually 2 since 3 squared is 9, so I'm just going to go ahead and simplify that, and then I have the log base 3 of x. Let's try one more like that. Let's say I have the natural log of 5x, y, z. Again, this is a product, so products become addition. So I'll have the natural log of 5 plus the natural log of x plus the natural log of y plus the natural log of z. So everything I have that was being multiplied turns into its own term in an addition expansion. So very similar to that, we have the quotient rule. So the quotient rule says when I divide, I subtract. So the log base b of m over n is the log base b of m minus the log base b of n. So notice as I'm expanding, each piece gets its own log base b. That could look like the log base 4 of 2x plus 3 over 64. So expanding, I have the log base 4 of 2x plus 3 minus now, because I'm dividing, the log base 4 of 64. In this example again, I can simplify this log base 4 of 64. So let's write that log base 4 of 2x plus 3 minus log base 4 of 64 is 3 because we know 4 cubed is 64. So if you can make a little simplification, I always encourage that. Let's try that again. Again, I like to do a natural log. So let's say I had the natural log, something simple like x over y. So when I simplify this, and it's really just a different look at it, so it's exactly the same expression, I'm just looking at it in a different way. I have the natural log of x minus the natural log of y. So this expansion just changes the look of our expression. The last rule we'll talk about is the power rule. So this is the log base b of m to the p. The p as the power comes in front as the coefficient, so it's multiplying the log. So I have log base b of m to the p is p log base b of m. So let's try a few examples. Log base 3 of x to the 5th, so that power 5 becomes a coefficient. I have the log base 3 of x. The next one, I have the natural log of the cube root of x. I want to write that as the natural log of x to the power 1/3. So we want to be able to go back and forth between radicals and rational exponents. Now that I've written as an exponent, I can bring the 1/3 in front. I have the natural log of x. So to kind of recap this, I'm going to put this all together. So this says, and let me put a parenthesis in there, I think that'll help. I have the log of x squared y to the 5th. Now this log, you don't see a base, so that says it's 10. It's a common log. I see two things going on. I see a multiplication and I see powers. So I'm first going to separate that by the multiplication. So I have the log of x squared plus the log of y to the 5th. You want to separate it before you bring the powers down because the 2 only belongs to the x, the 5 only belongs to the y. So the 2 comes in front, I have log x, the 5 comes in front, I have log y, and that's where I stop. Same kind of thing down here, I have the log of 7x divided by y cubed. So I see division, so I'm going to start there. I have the log of 7x minus the log of y cubed. Now, I definitely see a power here, and it kind of depends on what you're doing as to whether or not you're going to separate the 7 and the x. So I would say if you're in an algebra class and they're saying fully expand, then yes, you would do the log of 7 plus the log of x to say products turn into addition. And then that power 3 would come in front. I have log 3 of y. In calculus, you usually don't have to do the separation of the x and the 7. It'll be taken care of when you're doing derivatives. So it really depends on which class you're in to how much you would simplify. So this would be my answer if I was in algebra, but if I were in calculus, I would leave the 7x together because we have big rules that will take care of that. So let's just try a couple more. Let's say I had the natural log of x squared y over x plus 2, y minus 3. What I want you to see here is how much expansion do I need to do. So what I start to think is anything on the top, it's being multiplied. So it's going to be positive in the expansion. So I have the natural log of x squared plus the natural log of y. On the bottom, I'm dividing, so it needs to be subtraction. So you could do two steps. You could say minus natural log of x plus 2 times y minus 3. As we keep simplifying, I could take this 2 down, so I have 2 natural log of x plus natural log of y. And then I have minus, I can make this the natural log of x plus 2 plus the natural log of y minus 3. And this negative in front needs to distribute to both. So I have 2 natural log of x plus natural log of y minus natural log of x plus 2 minus natural log of y minus 3. What you end up seeing is anything in the top is positive, anything in the bottom is negative, and that is how I would go about it. I would not do all of these steps. What I would say to do is say I have the natural log, let's make it x to the 4th, y to the 5th over z w squared. I would do a one-step simplify. I would say the 4 is a power, it goes in front, natural log of x, plus 5 is a power, it goes in front, natural log of y. Those were on top, so those are positive. Z is in the bottom, I say minus natural log of z. W is on the bottom, I say minus 2 as the power, natural log of w. I say keep it simple. There's no reason to write these 3 rows of answers if you can see it and write it all at once. So think positive for the numerator, negative for the denominator, one step as your expansion. That'll make things nice and easy.